Okay, welcome back to our solutions of questions on introductory analysis. If you haven't subscribed to this channel and you are a student of real analysis or introductory analysis, kindly subscribe because I am going to solve more tutorial questions on your topics. Thank you. So we have this question on the board, which is we have a series. This is a series. And this series converges to S. Then what is the value of S? The value that it converges to, what is it? Okay. So this series, this question is actually simple. I have the series as k equals to 1 up to infinity of 1 over k plus 2 minus 2 over 3 power k plus 1, like this. So this is just a combination of two series. We have this part, so we can write it like this: k equals to 1 up to infinity of the first part, 1 over k plus 2, then minus k equals to 1 to infinity of 2 over 3 power k plus 1, like this. Okay, so right now this one here, we have to deal with it alone and come and deal with this one too alone. The sum of this particular series from 1 up to infinity. Okay, so right now we are going to employ the idea of partial fraction disintegration to find the form of this particular series, because it will look like a telescoping series, or in other words, alternating series. Also, let's see how we are going to do that. So by partial fraction, we have 1 over k plus 2 equivalent to a over k plus b over k plus 2, and this will imply have 1 equals to a k plus 2 plus b k, like this. Okay, and this over k plus 2, and this over k plus 2. But since this and this are the same, we equate the numerators. So we have 1 to be equals to a k plus 2 plus b k. So we use cover up. Okay, cover up rule. So we let k to be equals to -2. This will imply that we have 1 to be equals to a of 0, because if k is -2, and this one will be -2 plus 2, that's 0, plus b of -2. So we have -2b equals to 1. This implies b equals to -1 over 2. Okay, now what of the a? For the a, we let k to be 0, so let k to be equals to 0. So imply we have 1 to be equals to 2a plus 0, and so we have 2a to be equals to 1. It implies a to be equals to 1 over 2. So right now we have 1 over k plus 2 being written as the a is 2 over k minus 1 over 2 over k plus 2, like this, which we can actually write as half 2k minus 1 over 2k plus 4, like this. Okay. So we now have this one, so we can then write goes to infinity 1, sorry, that is 1 up to infinity of this. Okay, so right now we have broken this into this. Okay. So right now let's see, let's investigate when k is equals to 1, what will be the value of this series. Okay, and this will imply that we will have, when k is equals to 1, we just substitute 1 here and 1 here. Okay, and that will just be 1 over 2 minus 1 over 6. Okay, because 1 here, 1 in here will be 2 plus 4, that's 6. So we have this part for the when k equals to 1. Now when k equals to 2, what will we have? When k is equals to 2, we'll put 2 here, and that will be 1 over 4 minus, we'll put 2 here, that will be 1 over 8. Okay. Now when k is equals to 3, when k is equals to 3, we will have 1 over 6 minus 1 over 10. Okay, 1 over 10, like this. Now when k is equals to 4, let's see what you get. When k is equals to 4, we get 1 over 8 minus 1 over 12. Okay, now this will go on and on and on. This will go on and on and on. So as we approach, maybe we'll get maybe 1 over 2 n minus 1. Okay, n minus 1 means the last bisecond term, then minus 1 over, look at this, that will just be 2n minus 1 plus 4, like this. Okay, and then the last one, which will just be this one going, so we'll get something like 1 over 2 into brackets n minus 1 plus 4 again, and this one you get maybe the last one, which is just 1 over 2n plus 4, like this. Okay, so what is happening here, we are adding the series. Series means addition. So this plus this plus this plus this, going up to infinity. But see what is happening, this one and this one can cancel because this is negative and this positive. This one and this one can cancel because one is positive and the other is negative. So it will have happened that this one and 10 will cancel, but it's not there. Another 10 will, this one will cancel. So they will all cancel out except this one and this one. So we just add the 2. So that will imply that as we sum the series from k equals 1 up to infinity of 1 over k plus 2, this will become 1 over 2 plus 1 over 4, and this is equals to 3 over 4. Okay, that will be equals to 3 over 4. So that is the sum for that part. Now we then take the second part, which is, okay, second part, that is just sum of k from 1 up to infinity of 2 over 3 power k plus 1. Let's when, let's investigate. When k is equals to 1, what do we get for the series? So we have been putting 1 here, that will just be 1 plus 1, that's 2, 3 power 2, that's 9, 2 over this. So we have the series to be 2 over 9. Now when k is equals to 2, we get 2 over 27. When k is equals to 3, we get 2 over 81. Okay, and so on and so on and so forth. So this is kind of we have a geometric sequence. Okay, a geometric sequence, and it is infinite. The geometric sequence is infinite. So actually we can use the formula for finding the sum to infinity of a GP. Okay, so we know that sum to infinity of a GP is equals to this, a over 1 minus r, where a is the first term and r is the common ratio. Now what is the first term? This one we have 2 over 9, 2 over 27, 2 over 81 going. Okay, so the first term is 2 over 9. What of the common ratio? Common ratio is just found by common ratio is equals to maybe this term over this term. So 2 over 27 divided by 2 over 9, and this equals to 1 over 3. Okay, so this will imply that we have 2 over 9 over 1 minus 1 over 3. Putting this in your calculator, you just get this times this, that's 3 minus this over 2, so you get 1 over 3, like this. Okay, if you put this in your calculator, I think you get 1 over 3 again. So now, so that is the sum for the GP. So we now have two things. So we have k equals to 1 up to infinity of 1 over k into brackets k plus 2, now minus 2 over 3 power k plus 1. So we did all these two, and we realized this sum gave us 3 over 4 minus this sum gave us 1 over 3. And so if we do the arithmetic well, this is over 12, 3 here, get 9 minus 4, and so finally we'll get 5 over 12. That's our answer. Thank you for watching. Kindly subscribe for more tutorials.